Alright, in this lecture we're going to look at the final two cases here for solving oblique triangles. Case 3, which is side angle side, and case 4, which is side side side. Okay, two sides and their included angle, or all three sides. If you remember, we already looked at case 1. Two angles and a side were known. We had to use the law of sines, and then case 2 was the ambiguous case. We also had to use the law of sines, but in this one we could end up with 0, 1, or 2 triangles. In each of these final two cases, we will only end up with one triangle. All right? So to do that, we're going to use the law of cosines. So the first thing I want to do is derive the law of cosines for you. Now, we can position any triangle such that we put one of the vertices at the point 0, 0 in a coordinate plane, and then put one of the sides along the x-axis. Right? If angle A is acute, it would look something like this, and if angle A is obtuse, it would look something like this. Now, we can, if we say that this is the point 0, 0, we can get coordinates for the other two vertices as well. If this is point A, point B, and point C, this, since it's the side opposite angle C, would be side C, and we can say it has length C. That means the coordinates of point B would be C, 0. The y-coordinate would be 0. Now, for the coordinates of point C, we can derive those using a right triangle. So if I drop an altitude down from point C and create a right triangle here, what we can say, okay, to get the x and the y coordinates, first if I look at the x coordinate, with respect to angle A, this would be the adjacent side of this right triangle. So I could say, if I'm looking at adjacent, and then I know the length here is b, adjacent and hypotenuse would be cosine. So I can say the cosine of angle A is equal to adjacent over hypotenuse. So x over b. Now, to just get the x coordinate, I can multiply b over and say that x is equal to b times the cosine of a. That's where this x coordinate comes from right here. Similarly, if I want to get the y-coordinate, looking at this right triangle, with respect to angle A, this would be the opposite side, this would be the hypotenuse. So I could set this up by saying sine of angle A is equal to opposite over hypotenuse, y over b. So again, to solve for y, I can just multiply the b over and say that y is equal to b times the sine of a. So that gets me coordinates for this point. Now that would be true no matter what the values are here, no matter what the value of b, no matter what the value of angle A is. These would be the coordinates of point C. Now let's say that our goal is to find the length of side A. Well, to do that, we can use the distance formula. Right? And the distance formula is just a form of the Pythagorean theorem, but we know that, so let's say our goal is to find the length of A. The distance formula looks like this. Right? x2 minus x1 squared plus y2 minus y1 squared. So this is just saying take the difference in the x-coordinates and the difference in the y-coordinates. So if I'm finding the length of A, I'm looking at these coordinates and these coordinates. So I'll label these as x2 and y2, these as x1 and y1. All right. So if I plug these values in to the distance formula to find the length of A, I'll end up with b times the cosine of A minus c squared plus b times the sine of A minus 0 squared. And that's all under the square root. Now, it's probably going to be easier to work with this if we don't have the square root. So we can go ahead and just square both sides of the equation here. We can say a squared is equal to b times the cosine of a minus c squared plus, and then I can get rid of this minus 0 as well. I can just write this as b times the sine of a all squared. So now let's go ahead and square both of these things in parentheses. So over here, right, we can either FOIL, right, each binomial next to each other, or we can use our shortcut, square the first term. So there's two things there. So if I square this, I will have b squared times cosine squared of a. Then take 2 times the product of the two. So that would be minus 2bc cosine of a, and then square the last. So that would be plus c squared. And then over here, we just have one thing to square. So that would be plus b squared sine squared of a. All right. Now, we can actually simplify this a little bit further. If we look at this term and this term, they both include a b squared. So I can factor a b squared out of each of those and write it like this. B squared times cosine squared of a plus sine squared of a. And then we have our other two terms here, plus c squared minus 2bc cosine of a. Now this is our Pythagorean identity. Cosine squared plus sine squared is just equal to 1. So we end up with b squared times 1, which would just be b squared. So we get b squared then plus c squared minus 2bc cosine of a. And this is known as the law of cosines. Okay? Now, we specifically solved for side A here. We could have gone through this same process to solve for either B or C. Right? So we actually end up with 3 different forms of the law of cosines, but they all do exactly the same thing, right, depending on which side we want to solve for. Right? So a squared equals b squared plus c squared minus 2bc times the cosine of a. What that's saying is, if I know sides b and c and angle a, I can use that to solve for side a. Right? We would have this side squared plus this side squared minus 2 times this side times the cosine of the angle in between. And the same thing is true if we're given c and a or a and b. All right, so let's try using this to solve a triangle. All right, so this example says solve triangle ABC, where we know that A is 15, B is 10, and angle C is 60. So let's draw out our triangle, ABC, and then the side opposite angle A is 15, the side opposite angle B is 10, and then angle C is 60 degrees. Right? So this is a side angle side case. Now, the reason that we can't use law of sines to solve something like this, whenever we try to set up a proportion, right, let's try it. I could start with C. Since I know that angle, I can say the sine of 60 degrees over its opposite side, which we don't know, is equal to, now I could choose either of these, I guess. I could say the sine of B over 10. This proportion has 2 unknowns. I don't know side C or angle B. I can't solve this, so we cannot use the law of sines. That's why we have to use the law of cosines to solve this. So we can set this up. Okay, we can start by solving for side C. We can say C squared is equal to A squared, which would be let me write it out first. C squared is a squared plus b squared minus 2ab times the cosine of angle C. So now let's plug in what we know. So c squared is going to be 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of 60. All right. So we could actually go ahead and take the square root of both sides before we plug any of this into the calculator. And then we could put all of this in one line in the calculator. Square root of 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of 60. All right, so let's go ahead and plug that in the calculator. So square root of 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of 60. And if we're rounding to the nearest tenth, that would be 13.2. So we get that side C is 13.2. Now, again, remember when you're organizing your answer, make sure you're listing everything out like this. So we don't know angles A or B yet, but now we know all three sides. A is 15 inches, B is 10 inches, and C is 13.2 inches. All right, so now we can choose to solve for either A or B, and to do that, now we can use the law of sines. Right? The law of sines is usually a little bit easier to work with, so whenever you can, you want to try to use the law of sines. Now we can set up a proportion using this pair of opposite pieces. We have an angle and its opposite side. So I can set this up saying the sine of 60 over its opposite side, 13.2, equals, now it doesn't matter whether I solve for angle A or angle B first. I'll solve for angle A. So we'll say the sine of angle A over its opposite side of 15. So now cross multiply, get 15. Actually, just multiply the 15 over. Right? 15 times the sine of 60 over 13.2 equals sine of A. And to get A by itself, take the inverse sine of both sides. So we'll get inverse sine of all of this, 15 times the sine of 60 all over 13.2 equals A. And we can put that into the calculator. So inverse sine of, what was it, 15 times the sine of 60 sine of 60, close the parentheses, divided by 13.2. I get 79.8. So angle A is about 79.8 degrees. And then finally, to get my final angle, all I need to do is take 180 minus the two angles that I know. So 180 minus 60 minus 79.8. And that will get me, let's see, 40.2. and we have solved this triangle. Okay, so if we're given two sides and an angle in between, we have to start by using the law of cosines. All right. Now the final case is if we are given all three sides. All right, so here in this example, we have a triangle where we're given A, B, and C. So let's sketch it out first. So angles A, B, and C, then side A, which is opposite angle A, is 3.1. Side B, which is opposite angle B, is 5.4. And side C, which is opposite angle C, is 7.2. Now, again, we cannot use the law of sines to solve for one of these angles. Right? If we tried to set up a proportion, we would have two unknowns. So we can still use the law of cosines. Right? Now, if we look back at these forms of the law of cosines, we could actually take one of these forms and solve it for a missing angle. So let's take this last one down here and solve it for angle C. Right? Well, to do that, I would first subtract a squared and b squared over, right, and have c squared minus a squared minus b squared equals negative 2ab cosine of c. Well, now I could divide both sides by negative 2ab and get c squared minus a squared minus b squared over negative 2ab equals cosine of c. Now, we could proceed from here and leave that negative in the denominator, but usually you'll see it written like this instead. If I just divide everything by a negative, right, we could pull that negative out in front and say that this would really just be a squared plus b squared minus c squared over 2ab equals the cosine of c. Okay. So as long as we know this version of the law of cosines, we can use that to solve for an angle as well. Okay. So it doesn't matter if we use this version or this version. Okay. But the goal now is to solve for an angle using the law of cosines. All right. Personally, I just memorized this version, so I'm going to use this version in the example. Okay, but if you want to use this version, that's perfectly okay as well. So, again, it doesn't matter which angle we solve for first. Let's go for angle C. So I know c squared equals a squared plus b squared minus 2ab times the cosine of c. And I'm going to go ahead and plug in these values. So we're going to have 7.2 squared equals 3.1 squared plus 5.4 squared minus 2 times 3.1 times 5.4 times the cosine of c. So now we just want to solve for the cosine of c. All right? So subtract these over. 7.2 squared minus 3.1 squared plus 5.4, oops, it should be minus 5.4 squared if I'm subtracting it over. And then I'm going to do all of this in one step. Right? I'm going to go ahead and divide by this as well then. So divided by negative 2 times 3.1 times 5.4 equals the cosine of c. So now if I want to get c by itself, I need to take the inverse cosine of all of this. Okay, so I'm going to do all of this in one step in the calculator. So if I take the inverse cosine, it's just going to look like this: 7.2 squared minus 3.1 squared minus 5.4 squared all over -2 times 3.1 times 5.4. And that will equal angle C. All right, so let's pull up our calculator. So inverse cosine of, let's go ahead and get a fraction in here. That'll make it a little bit easier. So we've got 7.2 squared minus 5.4 squared minus 3.1 squared all over -2 times 5.4 times 3.1. Double check. Yep, that looks good. So I get about, if I round to the nearest tenth, that would actually be 113 degrees. So angle C, we find, is 113 degrees. And again, when we're organizing our answers, write it out like this. So we found this is 113. Now we know these three already. 1 feet. Now that we know a pair of opposites, right? An angle and its opposite side, now we can use law of cosines. I'm sorry, now we can use law of sines. So I could set up sine of 113 over its opposite side of 7.2 equals, and again, it doesn't matter which one I solve for first. I'll solve for angle A, so equals sine of A over 3.1, multiply the 3.1 over, and I'm going to go ahead and do this in one step. Right after we multiply the 3.1 over, then we'll take the inverse sine of both sides to get angle A. Plug that in the calculator. So inverse sine of 3.1 times sine of 113 divided by 7.2 . We get about 23.3. So angle A is 23.3 degrees. And again, to find the final angle, we can just take 180 minus the two angles we know now, minus 113 minus 23.3, and that will get us 43.7. Okay, so to solve a case where we're given two sides in the included angle, or where we are given all three sides, we first need to use the law of cosines to find a piece of information. after we use the law of cosines once, then we can use law of sines, which is a little bit less work. All right? We'll say, again, since this was a longer lecture, that this is Wednesday's work. Then Thursday will be some practice on this. And again, please send me any questions that you have.